सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत्। ॐ शान्ति शान्ति शान्तिः। Today in this session we shall take up the comparative study of Brahmagupta's geometry and Bhaskara's geometry. Now, how the scholars will fall in this pit? Brahmagupta, the essence of Brahmagupta's geometry is contained in 3 verses. Verse number 21, verse number 28 and verse number 38 in the 12th chapter of Brahmagupta Siddhanta by name Ganita. In verse number 21, he gives a formula for the area of a cyclic quadrilateral. In verse number 28, he gives formula for the measure of the diagonals of the cyclic quadrilateral. In verse number 38, he gives the rule for formation of cyclic quadrilateral. Formation of cyclic quadrilateral which are rational. Rational means the measure of the sides, measure of the diagonals are rational and also the area. Now, there we find in ancient India 2 types of scholars. That is 2 approaches towards quadrilateral. A school which considers the quadrilateral as a figure formed by the 4 parts of a circle, that is cyclic school. And a school in which it is considered as merely as the figure formed by 4 straight lines or 4 segments of a line are called as non-cyclic. Brahmagupta, Sridhara and Mahavadacharya belong to the cyclic school. Aryabhatta and Bhaskara belong to the non-cyclic school. Whereas Narayana Pandita has lineage towards both cyclic and non-cyclic. Non-cyclic scholars think that cyclic scholars are fools. Because they themselves do not know there will be 2 approaches for the formation of a quadrilateral. And strangely enough, they have omitted the cyclic quadrilaterals. Non-cyclic school, scholars of belonging to non-cyclic school have omitted the cyclic quadrilateral. That's why we draw the inference that they did not know the properties of the cyclic quadrilateral. Now, one by one, while studying the text, we should also see the sequence of the verses or order of the verses in which they are arranged, and what is the intention of the author. Why the sequence should be like that only. First, he condemns Brahmagupta. Condemns, khandana. So, phonetic similarity is there. Khandana and condemns. He condemns first Brahmagupta by saying, what is the verse there of Brahmagupta, verse number 27? Bhuja Prati, verse number 27 in Brahmagupta. The second part is Bhuja Yoga Chatustaya Bhujona Gata Padam Sukmam. Bhuja Yoga, leaving the formula for the approximate, if we consider the formula for the exact, Bhuja Yoga Chatustaya Bhujona Gata Padam Sukmam. This is the formula given by Brahmagupta. That means area is equal to A is equal to under root S minus A to S minus B, S minus B, S minus B. Now, this is the area for the cyclic quadrilateral given by Brahmagupta and specifying the quadrilateral as a cyclic quadrilateral using the word Tri Chaturbuja in the first part of the verse itself. That other scholars belonging to non-cyclic school could not understand it in the proper sense. So, first of all, what we have to do, if you have to disprove his rule, take an example in which four sides are given and calculate its area. Using the same four sides, if we show that there will be different areas, then rule will be disproved. So, he takes the same example given by Brahmagupta. Brahmagupta gave the first example in which the sides are 25, 39, 52 and 60. Taking the same example, he calculates the area and disproves it. But the thing is that Brahmagupta considered cyclic quadrilateral. A non-cyclic quadrilateral can also be formed using these measures. When we form a non-cyclic quadrilateral with the given four sides, if it is compared with the cyclic quadrilateral, what is the specific property? अब हम दिए गए 4 यूनिट मेजर से एक साइक्लिक क्वाड्रिलेटरल बन गए और दूसरा नॉन साइक्लिक क्वाड्रिलेटरल बने, इसमें डिफरेंस क्या होगा?
Cyclic quadrilateral more area than the other.
Yeah, exactly. You know, the area found by the four sides given, area will be maximum only in case if it is a cyclic quadrilateral. If the area is less, then that is a non-cyclic quadrilateral. Another aspect. So, for a cyclic quadrilateral, there are 3 diagonals, 3 and only 3 diagonals. Possibilities there are for the given four sides 25, 39, 52 and 60, 56, 63 and 65. These are the measures of the diagonals. Other than these diagonals, there will not be any other diagonal. So we use the term niyata karna or niyata shruti. Shruti means diagonal. So these are their dimensions are fixed. And the dimensions of the sides are fixed, then the dimensions of the diagonals are fixed. For the condition that area to be met. Parmeshwara says, if we take any other quadrilateral having different diagonals other than this, then the area found will be less than the cyclic quadrilateral. Now, first of all, he says, Bhaskaracharya says, the sthula phalam Bijaganita chatushtayam Bijaganita chatushtayam Bhujonaghata padam sukha. He says the area of the quadrilateral given by this sutra is approximate, whereas this interpreting three chaturbuja, tribuja and chaturbuja, area obtained for a triangle is exact. Sarvador yuti dalam bhujayogartha. The one and the second. Bhujayogartha जो है ना sarvador, do means sides. Sarvador yuti dalam chaturstitam bahurvir virahitam bhujona ghata cha vadha tad vadha. इसका पूरा फ्रेज का मीनिंग जो है ना भुजोना घाता पदम, उसका मीनिंग है मूलम, that is padam in Brahmagupta. Moolam asputa phalam, non-accurate or approximate phalam, chaturbhuje, in case of a quadrilateral. Spashtam evam uditam tribahuke. In case of a triangle, it will be exact. But not so with in case of a quadrilateral. In case of quadrilateral, the area obtained by Brahmagupta's formula will be approximate, whereas in case of a triangle, it is accurate. So here he has gone wrong, because he did not understood that the area is framed, the formula is framed from a cyclic formula. So to prove this rule or to prove this aspect, he gives two examples. Next, verse number 170. Verse number 170. Figure. Now, he takes a trapezium with the face 9, base 14, height 12, and one side 12, other side 30. Why he takes this example? To calculate its area easily and exactly. Now, 5, 12, 13. This is a right angle triangle. 5, 12, 13 is a right angle triangle. And 9 by 12 is a rectangle. So, what is the area of this trapezium? 12 into 9 plus half of 12 into 5. Now, consider this as A, B, C, D. According to the Brahmagupta's rule, under root S minus A, S minus B, S minus C, S minus D. He calculates the area. That area works out to A plus B plus C plus D by 2. 9 plus 12 plus 14 plus 13 by 2, that is 24. 24 minus 9, 24 minus 12, 24 minus 14, 24 minus 13. Take the product, take the root, the area is 141 square inches. The area obtained according to Brahmagupta's rule is 141 units, whereas the exact area is 138 units. So, he establishes his formula. He establishes his wrong formula, taking a wrong example. Why it is a wrong example? It is a trapezium and it is not isosceles. Only isosceles trapeziums will be cyclic. This is a general trapezium. General trapezium is not cyclic in nature. Now, next part. It takes the triangle 14, 15, 13. There are two right angle triangles. We can easily calculate the area. Then calculate the area by Brahmagupta's formula. It is 84. Calculate according to Aryabhata's formula. Samadana Koti Bhujarda Samvarga. It is 1 and the same. So he says 169 units. Moolam asputa palam chaturbhuje spashtameva uditam tribhavuke. So, Bhaskaracharya on here, wrong here. Next, he has disproved, according to him, that area given by Brahmagupta is wrong. Next, what we have to do? We have to disprove the diagonal theorem. That is, rules given to calculate the diagonals. Then what we have to do? 38, that is formation of rational factors. To calculate the diagonals, he uses the formula of abhada, avalamba abhada. Making use of abhada and avalamba, he calculates the diagonals. Verse number 186 and 187. Figures. Next. Here it takes four sides 25, 39, 52 and 60. He calculates two diagonals in such a way that AO is equal to 30 and OC is equal to 2. So AC is equal to 32 and BD is equal to 24. BD is equal to 76 integer 22 by 25. It is calculated the rest from. BD is equal to 76 integer 22 by 25. For the same given set of four sides, he has obtained two different diagonals other than this one, 56, 63 and 60. But he forgot that the area formed by that triangle will not be maximum. Next. So, by taking this, he disproves that the formula stated by Brahmagupta to calculate the diagonals will hold good only in certain cases, not for the general quadrilateral. Next. He takes other example. Same example 25, 39, 52 and 60. And taking it as a trapezium, he obtains the diagonals. There it is said only three diagonals are possible by Narayana Pandita. While exploring all these possibilities, one thing that Bhaskara found was, if we change the order of the sides of the quadrilateral, then we obtain one more diagonal, that is GR. PQR, EFG, the third diagonal will be GR. This aspect struck to Bhaskaracharya while verifying and disproving those things. So, some good things happen when condemning others also. Now, the diagonals of ABCD. AC is equal to 46 integer 13 by 20 and BD is equal to 71 integer 1 by 20. It is mentioned there. Now, he calculates the first one. They are mere calculations. The only content is for the same set of four sides. He calculated one taking it as a general triangle and another taking it as a trapezium. He calculated both diagonals. Then we have four diagonals, whereas he has taken two different figures and two diagonals for each figure. So he has calculated four diagonals other than this, and then he states a rule regarding Sthulatva Nirupana Niyama, verse number 171. 171. While teaching, you should arrange the verses according to the subject, or according to the order in which Bhaskara has given. I am teaching in the class. What he says, Chaturbhajasya niyataihi karunau katham tato asmin niyatam phalam syat. How there will be only niyata, that is, the diagonals are fixed in measure, and how the area is fixed. In the first class, if we stretch the diagonals, one diagonal is enlarged and other will be shortened. So there will be many triangles, many quadrilaterals, and many quadrilaterals, many different areas. So, Teshvev Bahushvaparocha Karnava Anekada Kshetraparam Tatascha. There will be many values for the diagonals and also for the area. So there will not be unique area and niyata karna. So by this he is trying simultaneously disproving the verse rule contained in verse number 21 and 28. Then he proceeds further. Verse number 188. One 189 and 190. Verse number 189 and 190. Before that, Brahmagupta's contract, formation of Brahmagupta's contract. That. दूसरा figure 2014 indicating all the sides. You enlarge this figure. Now, in Rule 38, Brahmagupta states a rule how to obtain the four sides of a cyclic quadrilateral. Then, when the diagonals cut orthogonally or perpendicularly, then the diagonal can be merely obtained by the sum of the product of the sides. AC is equal to FP plus EQ and BD is equal to EP plus FQ. Then what is the necessity of obtaining the formula that X is equal to under root AD plus BC into AC plus BD by AB plus CD? So I can't understand why Brahmagupta says like this. Then 18 and 118 and 190. He says, verse number 190. पूर्वैहि कृतम यद गुरु तन्न विद्महा. ऐसा हमने क्यों कहा मुझे समझ में नहीं आ रहा है. अब इतना शार्प मेथड रहने के बाद भी उसको और करना, ये करना, प्रोडक्ट करना, सम लेना, उसके बाद में रूट करना. I can't understand it, this rationale behind the rule. But he has gone. Why he has gone wrong? While if there are these three diagonals cut perpendicularly, if we take only 56 and 63, one set, then the shortest and the longest sides are placed opposite to each other. In other cases, the diagonals will not be perpendicular. If the diagonals are not perpendicular, we cannot apply that one. ER plus F figure. If the diagonals are not perpendicular, those 6 figures of. There will be 6 cases. Among 6 cases, only in 2 cases. Cyclic quadrilateral figure. Analysis of cyclic quadrilateral. Six figures. Presentation. Lecture, analysis of cyclic quadrilateral. This is presentation. So here it is possible. I'll just reduce the size. This is mirror. These are the mirror images. In only these two cases, diagonals cut perpendicularly, and it is possible. The other four cases, the diagonals do not cut perpendicularly, and it is not. समझ गए? So it is possible only now. It is perpendicular. Diagonals are not perpendicular to each other. Where the diagonals are not perpendicular to each other, if you add the segments, it will not make the. That is, if you add the perpendiculars drawn from the vertices. Now here in the triangle ABD, AO is the perpendicular drawn. It is the upper part of the diagonal AC. In the triangle BCD, we have drawn perpendicular from B to BD. So it is lower part of the diagonal. That's why they being collinear, we can add them, upper part and lower part. Take for example here. If we take FH as the base, if you draw the perpendicular from E, it will be here. If you draw from G, that will be like this one. So they are not collinear. So we can't calculate if we add them, it will not be the measure of the diagonal. So Bhaskaracharya has gone wrong here also. So his comment that na tanna vidmaha is wrong. Tanna vidmaha. Now we have to see how this has been solved by Parameshwara and Jeshtadeva. Scholars belong to the Arya school, Heroor school. Parameshwara says, if you consider the cyclic quadrilateral, they will be near the Shakti and the area is maximum. If you consider other diagonals, other pairs of diagonals, then the area will be less than that one. At one stroke, he has condemned Bhaskara. Then Jeshtadeva combines both. He is a good politician, Jeshtadeva. He says Bhaskara is correct and Brahmagupta is correct. But he changes the text itself. He changes, by changing the text, he gives credit to both Brahmagupta and Bhaskara. There is a research article in Kannada by me, which was published in August 2007 in Uttan. Now I will give the verse given by Jeshtadeva. How he has first verse number 189, Sarvado Yutut, which is 169. Verse number 169. You write down in your notebook, first verse. What is that? You write in this one. Sarvadavar itudalam chatussthitam bahur virviraitam chatadva moolam asputa palam. Especially this second line. Because to compare with the text, amended text. What is the amended text? Now, the amended text, the first line is as it is. Now, second line, amended text. Moolam atra niyata shritau phalam. Moolam atra niyata shritau phalam. Trasra bahujam api sputam bhave. This is the text amended by Jeshtadeva and incorporated in Shankara's Kriyakramakari. Now he says, Bhaskara says, Moolam asputa phalam chaturbhuje. Spashtameva mudittam tribhavute. What is that amended text? That Moolam atra. When we take the square root, atra, Shrutau niyata. Niyata Shrutau. Niyata Shrutau phalam. Then the area will be exact in case of niyata shrutau. That means cyclic quadrilateral in which the diagonals are niyata. Our next. Last. Trasra bahujamapi sputam bhave. So it will be exact in case of cyclic quadrilateral and also right. So if we have to take up this study comparative like this one. So Brahmagupta, next Sridharacharya, then Mahaviracharya, then Bhaskaracharya. Bhaskaracharya did not understand Brahmagupta, so he commented. Parmeshwara once condemned Bhaskaracharya, then Jeshtadeva commented those things. So this is the development of the subject. In such a way, you have to take it. Now, important things in Kshetra Vyavahara of Bhaskaracharya. These are the important things in the Bhaskaracharya's. There are two approximate formulas. There are two approximate formulas in verse number 204 and 210. Verse number 204 and 210. I will tell only the equations. Verse number 204. Now, consider reference circle. Let DB be the Purnaja, not a trigonometry. You have to remember Purnaja. CD be the height of the segment. To find CD, this is the formula. To find if you take DH as the diameter as denoted by small d, let DH be small d and CD be small h and AB be small c. AB, that is full chord, let it be small c, denoted by small c, the diameter DH by small d, arrow CD by small h, and let AC or CB. AC or CB, that is half the chord be denoted by S. Then the formula number 1, that is H is equal to CD is equal to, you substitute the values for those things. What you will obtain? H is equal to half of D minus under root D square minus C square. This is the first formula. If you substitute those things for the second, you obtain C is equal to 2 under root D minus H into H. It may also be written as under root 4H, that is if you take 2 in the root, it will be 4H into D minus H. Third formula, D will be equal to S square by H plus H, or D is equal to C square by 4 into bracket plus H square by H. These are where the formulas used in the Shubha Sutras also, and also in Jaina geometry. Very old sutras. Next, verse number 210. Verse number 210. It's only formula. फर्स्ट उसका फिगर बताना बाद में फिगर AB is the पूर्णज्या. AC square plus AB square is equal to BC square. Now here the formula is given to find the full chord. Let AB be is equal to A. Let AB be equal to A, and let C be the circumference of the circle, and D its diameter. Then formula number 1. These are the steps. Prathama. After 3 steps, we will arrive at the result. S is equal to, that means AB is equal to 4, number 4, Roman 4. S is equal to 4 into D into C minus A into A by 5C square by 4 minus C minus A into A, where A is equal to the full chord, C is the circumference, and D is the diameter. Using these things, we calculate AB. There are 2 good formulas stated by Brahmagupta himself, not in 12th chapter but in other chapters. They are concerned with trigonometry and also geometry. It will be stated later in person. So, this is all about the comparative study of Brahmagupta geometry and Bhaskara. Now you may ask your doubts and questions. I think you are clear about the way in which you have to make the comparative studies.
So, did they have to make some practical use of cyclic quadrilaterals in those days? Because of which they were concentrating, like Brahmagupta and all were concentrating much on cyclic quadrilaterals.
Once again, it has to be studied. Suddenly, I cannot answer that. So, अभी कुछ तो आंसर बोलना ठीक नहीं रहेगा. Pinpoint it where it has been used and why it is so. Usually, the calculation of Jharkhanda regarding calculation of sine table, we construct those things. It may be one of the reasons for studying the cyclic figures as a whole, not as a quadrilateral. Considering the regular figures as cyclic figures. For example, एक ऐसा रहेगा. If you draw in a circle a hexagon, if you draw in a circle a hexagon, draw a hexagon, regular hexagon. First you take first side, second side, or you may take here also first side, parallel side. Let this be the center. This is an equilateral triangle. What is its side? Equal to the radius. What is the angle?
60 degrees.
So, what is this angle? 30 degrees. What is this measure? Half of hour. Ja of 30 degrees is equal to भुजार्ध तुल्य. भुजा कितना है? रेडियस है. भुजार्ध तुल्य. Half of the bhuja. So, for obtaining sin 30 degree, sin theta where theta is equal to 30 degree, they have taken half. By constructing regular figures in a circle, they have obtained, if we construct a square, then we will obtain for 45 degree. So, they tried like this one. So, for their prime requirement was to construct sine table based on the geometrical properties of the figures. So, they have ever done, हम कुछ तो ढूंढने जाते हैं, कुछ तो मिल जाता है. वैसा ये एक होगा. तो जो सूत्र है, वो सूत्र को ही आधार करना चाहिए. Internal evidences of this. So, this formula is given in RFD. Probably it may be 6th verse in 2nd chapter. षड्भुज के और no any questions, any more questions?
So can we have? Sorry.
I do not remember exactly the pattern, but षड्भुजस्य भाव विष्कम्भार्धेन सातुल्य. विष्कम्भार्धेन सातुल्य. विष्कम्भ means diameter. षड्भुज का भुज क्या होगा? It will be equal to विष्कम्भ, that is diameter. Half the diameter will be the भुजा of the षड्भुज. वो ऐसा है. वो पट्ट जो है ना, आप वेरीफाई करना. Any questions?
Anything related to whatever we have covered till now?
From first session up to this session. भी बहुत हो गया. अब क्या कुछ नहीं.
That's only doubts session. Other things, classes were not. It's a non-consent.
This was.
This one.
Verse number.
Verse number. We do not the implement figure.
210 is this. One, the figure.
Yeah. This one.
Yeah. You want that formula. That is all. 207.
There you should write down what is AB, what is BC, etc. And using the symbols, you arrive at the formula. Actually, it is not written like this in any commentary. Because to ease, I have given those symbols. To ease the students. उनको इसमें ये फार्मूला आ जाता है. Substitute the value to get the answer. आप में से कौन तो ऐसा लीलावती का भाष्य या ट्रांसलेशन लिखे तो अच्छा होगा. Using comparative. हाँ, नहीं comparative. First verse, then its अन्वय in Sanskrit, and translation according to अन्वय. प्रतिपदार्थ के साथ जो है ना उसका a sentence. If you read the sentence in close, it should be like the अन्वय itself, but in the other language. Then after first verse अन्वय, then translation, then vivarana. In vivarana you should write this trija is denoted by R, area is denoted by A. Then what is the content of the verse in the form of a equation, in the form of algebraic equation. So there it ends with footnotes. इसको जो है ना कौन कौन इन द क्रोनोलॉजिकल ऑर्डर क्या क्या हुआ है, अगर एनी कमेंट्स है तो आपका भी अगर कमेंट्स है तो उसमें फुटनोट कर दीजिए. दिस विल बी a good study of India.
This translation it will be more we can do more comfortably in regional language, right?
Yeah, that's what I am telling. That's what. Then that translation should be according to the अन्वय. भावार्थ नहीं है. मतलब जो है ना वो this sentences also should be in the same order as in the verse, original verse. वैसा ट्रैक वो बहुत हार्ड है. इतने का आसान लगता है जो है ना regional language और संस्कृत will vary. Formation of sentences. वैसा
प्रोफेसर नाहो पढ़ के given in Marathi in 1971 he have completed this book and somewhat it is
like that.
It is like that.
Yeah.
Standard one book.
Yeah. Standard authors will do like that only. So you think about you will be a standard author in future.
And one more thing, can we say that Indian mathematicians only dealt with applied mathematics, not pure mathematics? Can we say that? Because whatever we are seeing, they are applied mathematics.
Indian mathematics dealt with mathematics with प्रयोजना. वो समस्या जब आता है, वो समस्या का समाधान ढूंढने के वास्ते जो है ना उन्हें थ्योरी जो है ना डेवलप किए. तो it is definite that while developing the theory, some what they have retracted. That means theory for theory's sake. The own motto is to apply science. उनको जा टेबल क्यों कंस्ट्रक्ट करना था? उनको ऑब्जर्वेशन के वास्ते जा टेबल कंस्ट्रक्ट करना था. जब जा टेबल में एक्यूरेसी पाने के लिए क्या होना चाहिए? इंटरपोलेशन होना चाहिए. First they tried linear interpolation. The result was not good. Then they took second order interpolation with first difference and second difference. They find the new things. ऐसा जो है ना need is the mother of invention. वैसा हम accuracy बढ़ाने के वास्ते शोध नया शोध चलते गया. First geometrical construction of the sine table. There is some limitation. Then construction of sine table using trigonometry, that is bhavana tattva. Bhavana tattva in trigonometry is sin a plus b. That is called as bhavana tattva in a trigonometry. Sin a plus b, sin a cos b, cos a sin a. So other method. And using trigonometrical identities, Bhaskara has given 6 methods of forming table in Jyotpatti. This is another method. Then Aryabhata's method of calculating sine table. Then difference method. Madhava's method, where he uses a series. ऐसा जो है ना कौन सा method से sine table broadly classifying geometrical, trigonometrical, difference method and series method. There are 4 headings. One geometric, trigonometric, and the difference and series. ऐसा उसमें accuracy series में ज़्यादा है, केवल तो series में number of times terms will be there. And Nilakanta Somaiya ji, instead of taking infinite terms, if you take 3 terms or 4 terms or 5 terms, and if we add a bija correction, a correction term, we should get, that means 5 terms, first 5 terms, then a correction. It should yield result such as taking 100 terms. That correction term क्या रहना चाहिए? ये नीलकंठ सोमैया जी बहुत अच्छा है. And he has given 3 correction terms also. And one of them equals to Leibniz series. Leibniz series को equivalent है. So Leibniz is later person. So Leibniz series से हम जो जानते हैं वो जो है ना पहले ही नीलकंठ बताए. ऐसा स्टडी करते हुए उसका क्या हुआ during construction of sine table and to the accuracy, Brahmagupta invented a theory of interpolation. Govinda Swami, he has contributed another thing in theory of interpretation. In the case of construction of sine tables only, three new things are stated by Govinda Swami. Govinda Swami's construction of sine table. गुप्ता जी का एक बहुत बड़ा आर्टिकल, about 40 articles of Gupta, R.C. Gupta is there on trigonometry. सभी आर्टिकल्स जो है ना बहुत अच्छे आर्टिकल्स है, उसमें ओरिजिनल में देते हैं और उनका कमेंट्स भी देते हैं और इक्वल इन द फॉर्म ऑफ इक्वेशंस इन द मॉडर्न फॉर्म. So using all his articles, I have a written book which is ready 3 years ago, not yet printed in Kannada, covering every complete trigonometry in 11 chapters. About 300 pages are.
It is in connection with what Professor asked. How about, is there anything, I have not read the Bijaganita part of this Bhaskaracharya, but then what they call it as a Bijaganita, how does it differ than the algebra, modern algebra and finite?
There is no difference at all. There is no difference between the modern algebra and Bijaganita stated by Bhaskara.
But then it means theoretical.
No?
Then modern algebra and algebra of finite elements.
Modern algebra means solution of equations, linear equations, quadratic equations, cubic equations, biquadratic equations, and simultaneous equations. Equations involving products.
No, it's not that group ring.
No, that's why I am telling solution of equations, not groups, rings. वो कल्पना नहीं है, वो कल्पना जो है ना बीजगणित में नहीं है. That is only solution of equations. That equations may be determinate equation, indeterminate equation, first degree, second degree, involving two variables, involving many variables. एक वर्ण समीकरण, अनेक वर्ण समीकरण, भाविता, that is consisting of the products. So modern algebra in the sense group rings set there, it is not there. It is only after 1940. It is only after 1940. वो भी बहुत पुराना नहीं है. इस सेट का कल्पना जो है ना 1940, उसके बाद जो है ना ये सब डेवलप हो गए सर. But the base we consider षड्रिधम, करणी षड्रिधम एक सब्जेक्ट, उसमें जो है ना रूल्स. Take for example commutative law. हम कम्यूटेटिव लॉ छोड़ देंगे क्या होगा? हम यूनिट एलिमेंट छोड़ देंगे क्या होगा? पॉसिबिलिटीज. अब पहले जो है ना हम विष्णु का मूर्ति बताए, having different articles in its different stands, so the number is 24. वो कंडीशन निकाल देंगे, डिफरेंट कंडीशन निकाल देंगे, कितना होगा? 4:4. ऐसा जो है ना by varying the conditions क्या बन सकता है ये सोच जो है ना बाद में. This is only theory for theory's sake. Or, for example, you take a paper, strip of paper, you give a twist to it and attach it. हर पर ये thread दिखेगा. So it goes to topology. एक पेपर ले लाना, उसको एक साइड करके फिर लगा देना. एक छोटा इसको पढ़ सकता हूँ. That means you place your pen on this side of the paper and draw a line, so that the other face, the line should continue on the other face also. What you have to do? You have to twist like this and like this. Study of such figures will be in topology. जो है ना पहले क्या किए थे? प्लेन फिगर्स कर दिए थे. बाद में जो है ना इसको रबर का स्टडी कर. If you like, this will be a circle. Instead of doing like this, if you attach like this with one turn, वो जो है ना टोपोलॉजी बनेगा. So while teaching, we should not teach the groups things. What is the necessity? अब मैं बता देना पेपर को बच्चा समझता नहीं है, उसको ग्रुप माने मालूम नहीं है, रिंग माने मालूम नहीं है, उसको टोपोलॉजी इंट्रोड्यूस करना है. टोपोलॉजी एक पर्परे ಅದಲ್ಲಪ್ಪ ಆ पर्परे ಹಚ್ಚು, you place your pen and draw line. It should be on the both sides of the paper. इसको ये प्रॉब्लम को कैसे आप सॉल्व करेंगे, इसको जो ना अगर सॉल्व करना है तो टोपोलॉजी में सॉल्व कर सकते हैं. उसको ये चाहिए. These are the prime requirements का है. ऐसा जो है थियरी डेवलप होता है. हमको for the pure mathematicians it is difficult to think of the concepts applied क्यों है. It is easy for me because I am an engineer. ऐसा जो है the pure mathematicians should try to be themselves as applied mathematicians. जो है ना theory develop हो जाता है. वो क्यों चाहिए? For example, what is the necessity of I? Draw x-axis and y-axis. 0, A, B. A, capital A. While we denoting the points, we should use the capital letters. While we denoting the distances, we should use small letters. A, B, C. Now, mark the points at equal distances. That is a number line. From right to the right, from O, it is positive number. To the left, it is negative number. अब जीरो किसने ऐड करना है? समस्या. जीरो राइट में है क्या? जीरो लेफ्ट में है. समस्या शुरू हुआ. हाँ, वो सेंटर में है. अब कौन सा नंबर में ऐड करना है? So we called 1 to n and any infinite numbers as natural numbers. तो एक को लगा जीरो जो है ना पॉजिटिव में ऐड कर देंगे. जीरो जो है ना पॉजिटिव नंबर में ऐड कर दिए और उसको एक नया टर्म चाहिए. दे कॉल इट एज होल नंबर्स. ऐसा जो रिक्वायरमेंट है उसके मुताबिक चले जाते हैं. अब हम एक कर्व ले लेंगे. लेट ऐसा एक कर्व ले लेंगे. इट इज साइन कर्व. दैट इज प्रोपगेशन ऑफ साउंड. That is represented by this propagation of sound. Or waves in a river, or waves in a lake. ये जो है ना ऐसा हो गया. इसमें क्या हो रहा है? It is only in 2 dimension. ये ऊपर गए तो पॉजिटिव होना, नीचे गए तो नेगेटिव. इसको कैसा बताना? एक ही फंक्शन रहना. अगर ऊपर गए तो पॉजिटिव होना, नीचे आए तो नेगेटिव होना. एक ही फंक्शन में होना. मैं क्या बताता हूँ यहाँ पर? This is I square. This is I square. This is I4. I square is -1. I4 is +1. इसका जो है ना पॉजिटिव नेगेटिव होना चाहिए. That's why I was required. अब इसके बाद जो है ना कॉम्प्लेक्स नंबर्स. I think to know them who know complex numbers. X plus I/y is a complex number. कॉम्प्लेक्स नंबर क्यों चाहिए? ये प्लेट में जो है ना कर्व हो गया. मैग्नेटिज्म में क्या होता है? राइट हैंड थंब रूल, लेफ्ट हैंड थंब रूल. अगर करंट ऐसा पास होता है तो मैग्नेटिज्म ऐसा होता है. अब मैग्नेटिक वेव्स और इलेक्ट्रोमैग्नेटिक वेव्स को हम 2 डायमेंशन में बताना है. कैसा बताना? सो टेक ए प्लेन परपेंडिकुलर टू दिस वन. Take a plane perpendicular to this one, like this one. One is एक जो ना कर्व ऐसा है ऊपर और नीचे. एक कर्व ऐसा है. दोनों का दोनों को मिलाना है. कैसा मिला सकते हैं? ये एग्जिस्टिंग ज्योमेट्री से नहीं होता है. नया चीज चाहिए तो नया चीज लेंगे. अब गुलबर्गा वाला को डोसा बनाना है. वहां पर जवाब रहता है नया चीज चाहिए तो राइस लेके आना चाहिए. पराठे बनना है तो वो क्या चाहिए वो लेके आना. सो लाइक दैट वन टू एड्रेस द प्रॉब्लम्स इट इज पॉसिबल. ऐसा एक प्लेन तो एक प्लेन परपेंडिकुलर कब होगा? इफ यू गो टू द not real field, complex field. I said, how to denote a complex number? How to denote a plane? How to denote a curve? ये क्यों मैंने लिया बोले तो now the scholars belonging to Sanskrit do not know what is a complex number, what is a complex field, what is a real field. ये रहने से यहाँ पर हमारा शाना तुम बताने का नहीं है. Because you have asked a question, so क्यों नहीं हुआ बोले तो नीड नहीं था. जब नीड अराइज हुआ उस वक्त नया नया चाहिए हम लिए. और भी नीड आता है, इतना ही सफिशिएंट नहीं है, और चाहिए. वो क्या चाहिए? पहले जो ढूंढता है ना, he will be with some advantage. So why shall ourselves be not with some advantage?
I have 5 more minutes. You want to make the maximum use of that water. Today is the last day, so you can squeeze out the maximum from sir.
When we use vectors and scalars, vector algebra, vector calculus, the calculation will be very very short. जो calculation other in engineering terms, graphics is the best subject, but most of them do not understand it. अगर प्रॉब्लम्स ग्राफिक्स में बहुत अच्छा अंडरस्टैंड हो गया तो एकदम जो है ना स्ट्रेसेस स्ट्रेस विल बी डिटरमाइंड. पैरेललोग्राम ऑफ फोर्सेस we study usually in the 9th and 10th standard. In the parallelogram of forces, we say if two forces are represented by the two sides of a, if the two forces are represented by the two sides of a समांतर चतुर्भुज, then this will be the result. By using vectors, we easily obtain it. Let A and B be the vectors. Notation of a vector is an arrow mark on the parameter. उसको डॉट प्रोडक्ट लेना, क्या क्रॉस प्रोडक्ट लेना, डॉट प्रोडक्ट ले तो एकदम आ जाता है. और क्रॉस प्रोडक्ट क्यों चाहिए? अगर हमको उसको वो जो प्लेन बनता है, एक प्लेन जो बनता है उसका परपेंडिकुलर एक चाहिए बोले तो जो है ना क्रॉस प्रोडक्ट चाहिए. सो व्हाट इज द नेसेसिटी ऑफ डॉट प्रोडक्ट एंड क्रॉस प्रोडक्ट? तो डॉट प्रोडक्ट एंड क्रॉस प्रोडक्ट जो है ना अलजेब्रा में आता है. नेक्स्ट ये जो है ना, फॉर एग्जांपल टेक ए स्पाइरल. How to know the equation? अब बकेट में जब कपड़ा एक करते हैं ना, वो हिल जो होता है उसका इक्वेशन होना है. क्या करना? वो इक्वेशन जो है ना वेक्टर कैलकुलस से बहुत इजी निकाल सकते हैं. वेक्टर कैलकुलस ऐसा we should have a set of ready-made problems which are application of the theory. For example, you are teaching matrix. While teaching matrix, you say, let there be a set array of numbers. Array of numbers. So, student पूछेगा, why should we consider an array of numbers? Instead of that, if you say, there are 4 persons. There are 4 persons equally rich, but not in cash, in kind. Let C denote cows, B denote buffaloes, and H denote horses, and D denote donkeys. He possesses some number of cows, some number of buffaloes, some number of horses, and some number of donkeys. Let those persons be X, Y, Z, and W. but they are having different numbers. First, I denote that first column should be reserved for cows, second column for buffaloes, third column for horses, and fourth column for donkeys. They have different prices for each. If you take this sum, they are equally rich. So, when we give the convention, the first column stands for cow. Columns cannot be changed. If we change the column, cow becomes buffalo, buffalo becomes horse. We can change the row. पहला विनय रहे तो क्या है, पहला पद्मनाभ रहे तो क्या है, उसको 4 आदमी का लिखना है, कौन सा भी पहले कौन सा भी दूसरा लिखने से कुछ होने का नहीं, डिफरेंस होने का नहीं है. So row can be changed without changing the meaning. ऐसा अगर हम सिखाए तो हाँ, हम ऐसा सिखाते हैं मैट्रिक्स एंड array of numbers where the columns cannot be changed, rows can be changed. भाई, you give an example. दोबारा पूछेगा नहीं फिर. हास डाउन की बनता है, डाउन खासी बनता है तो हाँ ठीक है यार, चेंज नहीं करना. Column should not be changed. If we change, then value will alter. The value of a matrix is called as determinant. Value बताने के वास्ते क्या है, स्थूल और सूक्ष्म. पहले ही हम सूक्ष्म नहीं बता सकते. पहले स्थूल atom, the smallest particle of an atom, which is individual. और actual individual है क्या? Individual नहीं है. उसके बाद में क्या करते हैं, एक न्यूक्लियस है, वो इंडिविजुअल है और इलेक्ट्रॉन्स थिंग्स रिवॉल्व अराउंड दैट. फिर जो है ना, हाँ, न्यूक्लियस जो है ना, प्रोटॉन है, न्यूट्रॉन है. तो न्यूट्रॉन क्या है, पॉजिट्रॉन और इलेक्ट्रॉन, ऐसा बताते चले गए तो देयर आर अबाउट 121 पार्टिकल्स इन द न्यूक्लियस इटसेल्फ. ऐसा हम एकदम जो है ना सूक्ष्म नहीं जा सकते. फिलोसफी में भी वैसा स्थूल, बाद में